All right, Chapter 8, review test. This is for the rational functions chapter. Number 1, what is the horizontal asymptote for this function right here? Now, you can certainly consult the notes or memorize the 3 cases for the horizontal asymptotes. Okay, there's 3 cases, but if you think about it logically, you don't even need to memorize it or consult the notes. If you think about it, as x approaches infinity, in other words, as x gets larger and larger, what happens here? Well, this exponent is to the 4th power, and this exponent is to the 3rd power. So what is going to increase faster as x goes to infinity, the numerator or the denominator? Well, clearly the numerator will get larger, faster, because that is raised to the 4th power while the denominator is raised to the 3rd. So if the numerator gets larger and larger, faster than the denominator, that means the y value is also going to approach infinity, right? If the numerator gets larger faster, the denominator gets larger faster. And if y is going to infinity, in other words, the vertical part is going to infinity, there is no horizontal asymptote, okay? There is no limit to how high the y value is going to be. So there's no reason to have a horizontal asymptote. So that is just answer C. All right, so if you consult the notes, it's going to say that if the degree of the numerator is greater than the degree of the denominator, then it's none for the horizontal asymptote. All right, so that's what it would say in the notes, but you can just figure it out. Number 2, what is the horizontal asymptote for the graph of this function here? All right, so this one's pretty simple. Look at the highest exponent or the degree of the numerator. That's a 3. Look at the highest exponent or the degree of the denominator. That's a 3. When the degrees are equal, you basically take the leading coefficients and make a fraction out of it. All right. So the leading coefficient is the coefficient with the variable with the highest exponent. So here it's a 2. And over here, the leading coefficient is a 5. All right. So the horizontal asymptote, and remember for a horizontal line, if you have a graph, right, and you draw a horizontal line like so, that line is going through the y-axis. So the graph, the line equation for that asymptote is going to be y equals. And in this case, y equals 2/5. All right, so again, remember for horizontal asymptote, there's 3 cases. And in this case, the degree of the numerator equals the degree of the denominator. You just take the coefficients and you make a fraction out of it. So that's y equals 2/5. All right, so that is answer B. Number 3, what is the horizontal asymptote for the graph of this function here? Once again, if you have it memorized, or you need to consult the notes, that's fine, but you really don't need to. Okay, look at this function here. What happens as x goes to infinity? Well, look at the degree of the numerator. That's a 2. Look at the degree of the denominator. That's a 3. The denominator is going to increase much faster because it's to the 3rd and this is to the 2nd power. Okay? If the denominator gets bigger much faster, you are going to have a number over infinity. Okay? And if the denominator gets larger and larger, you're dividing by a larger and larger number. the overall fraction is going to get smaller and smaller, and y is going to approach 0. All right, so basically the horizontal asymptote is y equals 0. Remember, the asymptote is a value that the graph approaches but never reaches. So the y is headed to 0, but it never reaches 0. That's why there's an asymptote there. All right, and of course, if you look at the notes, it's going to say that if the degree of the denominator is greater than the degree of the numerator, then the asymptote is going to be y equals 0. All right, so basically that's your answer, y equals 0. And that is answer A. Number 4, what are the vertical asymptotes for the graph of this function here? All right, they made it easy for us because they factored the denominator. All right, so that makes it real easy. The vertical asymptote is when the denominator equals 0. All right, so if I set this equal to 0, x plus 2 times x minus 1 equals 0. Either one of these can equal 0 because anything times 0 is 0. So if we do x plus 2 equals 0, minus 2 on both sides, x is negative 2. If I do x minus 1 equals 0, and I do plus 1 on both sides, x equals 1. All right, so negative 2 and positive 1. Answer B. All right, so that is for vertical asymptotes. And you set the denominator equal to 0 and solve. If it weren't factored, we would have had to factor this. Number 5, what are the intercepts for the graph of this function here? All right, for the y-intercept, that's when x equals 0. So pretty simple, you plug in 0 in place of x. You got 0 squared plus 1 divided by 0 minus 4. Zeros cancel, and 1 over negative 4 is going to be negative 1/4. All right, and now for the x-intercept, you set the numerator equal to 0. All right, so x squared plus 1 equals 0. If I do minus 1 on both sides, x squared is negative 1. And now the only way to solve this is with imaginary numbers, but intercepts cannot be imaginary. So since there's no real solution, there's no real numbers for this one, there is no x-intercept. All right, there's none, because this cannot be true for real numbers. All right, let's see. Answer A. There are no x-intercepts, and the y-intercept is negative 1/4. Number 6, what is the slant asymptote for the graph of this function? All right, remember the slant asymptote occurs when the degree of the numerator is exactly 1 more than the degree of the denominator. Okay, and we can see this degree is a 2, and this degree is a 1. The numerator is exactly 1 more. Anyhow, in order to find the slant asymptote, you just divide and ignore the remainder. So we're going to divide this. You can use long division, but we don't need to. When you divide by x plus 2, and you want to use synthetic division, you just use a negative 2 out front. All right, and make sure for these values that the exponent on the x's count down by 1. So here's 2, 1, 0. All right, so we don't have to add in any zeros for the coefficients. All right, so -2 out front. You leave enough room in the bracket for 2 rows. Okay, this coefficient is a 2. This coefficient here is a +1. And this coefficient here is a -1. All right, pretty simple. You bring down the 2. -2 times. All right, -2 times 2 is -4. And we are adding vertically. 1 plus -4 is -3. And really, we're done right there. If you want to continue, you can, but you do not need the remainder. Okay, you don't need it. So this right here would just be the remainder. That's unnecessary. And the 2 is times x. What's the exponent on this x? Exactly 1 less than the highest degree of the numerator. The highest degree of the numerator was a 2. So the exponent here is a 1. Okay, and then it counts down by 1. So this is -3. All right, so we need the 1 exponent? No, we do not. Okay, so it's just 2x minus 3. And of course, that means the slant asymptote is y equals 2x minus 3. Okay, an asymptote is a line. So the equation for the slant asymptote should be in the form of y equals mx plus b. But anyhow, that's it. Y equals 2x minus 3. That is answer B. All right, so remember, for the rational function here, if the degree of the numerator, this here is an exponent of 1. If the degree of the numerator is exactly 1 more than the degree of the denominator, that is going to give you a slant asymptote, and you just divide. Number 7, the graph in figure 813 is the graph of which rational function? Okay, so we can probably narrow it down with maybe an intercept and the vertical asymptotes. Just looking at the graph here, all right, this is the x-axis, and this is the y-axis. And what's the equation of each asymptote? Well, this one here, the vertical asymptote, is going right through x equals 1. All right, so this one here, this asymptote is going to be x equals 1. And this one here is going through y equals 1, so this asymptote is going to be y equals 1. All right, so let's find the equation with these asymptotes. And let's see, we have an x-intercept at -2, and we have a y-intercept at -2. All right, so those are the hints we can use on the equations. So let's go to the equations. All right, let's see. Remember, for the vertical asymptote, you set the denominator equal to 0. So right here, it's going to be x equals -1. Right here, it's going to be, let me separate these so you guys can see them a little better. All right, this is answer A, B, and C, D. All right. So let's see. Right here, if you set this denominator equal to 0, the vertical asymptote is going to be x equals 1. Right here, the vertical asymptote is x equals 1. And right here, the vertical asymptote is x equals -1. All right, so our vertical asymptote is x equals 1. So anyone that doesn't have that, we're going to eliminate. All right, here it says -1, eliminate. Here it says -1, eliminate. So we narrowed it down to 2 of them. All right, now let's see what else we can do. All right, so this is gone and this is gone. Look at the numerators. What happens when the numerator is 0? Well, that is your y-intercept. Okay, y-intercept is when the numerator equals 0. Nope, that's a mistake. Because if I plug in x equals 0, that's my y-intercept. X-intercept. X-intercept is when y equals 0. Okay, so in other words, the numerator. So in this case, what would make this 0? Well, that would be x equals 2. All right, so here the x-intercept is 2. And right here, in this numerator, if I set this equal to 0, what would make this equal 0? X equals -2. So for this x-intercept, it equals -2. Which one of the graphs have this? Well, let's see. The x-intercept here is at -2. This x-intercept says it equals +2. So that one's gone. And we have it narrowed down to answer C. All right, so that's basically it. The horizontal asymptote is the same on all of them. We have x over x. The degrees are equal, so it would just be 1 over 1 or just 1. So the horizontal asymptote would be the same on all of them. If you want to double check answer C, you can do the y-intercept just to double check. And the y-intercept is at x equals 0. So if you plug in 0, you have +2. If you plug in 0, you have -1. So that's going to be 2 over -1, which is just -2. Make sure the graph has -2 as the y-intercept. Yes, indeed it does. That the y-intercept is -2. So it checks out as your final check. So process of elimination, answer C.